I trip to the junk store today to buy some resistors. I'm nervous that the junk store is going to close down for good, so I'm trying to go there and give them my business and make sure that I scrounge every single nook and cranny in the store and get everything that I need before they disappear. Their building got bought by Amazon and they have to move somewhere, and with rent these days it might just disappear. So I don't know how much money they actually make off the junk business. They have another business and they probably make money off of that, surplus furniture and stuff, but I'm not sure if this particular part of their industry, of their business model actually pans out or not. But anyway, so I went and bought some resistors, and I want to do a video on these resistors, and I want to use these for projects, and I want to talk about this resistor. All right, so what are these? These are the little, I think these are 500 ohm. Can I zoom in farther? Yeah, I can zoom in farther. These are like little 500 ohm guys, and these are, I think, 10K. The reason I like these is they have little wheels on them, and they're single turn, so nice for little projects. I like those. So these are all 20 cents each, so that was good. Stock up on those. These were also 20 cents, and I thought I would do a video on these. I'll probably extend this video and do this video first. And this will be about dummy loads. I think people spend way too much money on things for ham radio and other things, and you should just build your own stuff. It's way cheaper. So we're going to build these. And then there was this cool resistor here, so let's talk about this one. Kind of looks like a fuse holder, right? It's threaded, and it has two connections on the end, so it looks exactly like a fuse holder if you first looked at it. But it's actually a resistor. It's a Dale resistor, and it says it's 25 watts. And there was a big bin of these of all different values. And looking at them, they were all used. So I don't know what these came out of or how these came about. But these are, like I said, they were different values. So I got one that I liked, which was a 0.5 ohm. So a lot of times you want to monitor current in a situation that you don't want to drop a lot of voltage. So yeah, this would be a pretty good value. Sometimes they use 0.1s, 0.01s even in really high current applications, but 0.5 ohm should be good. So let's test it, make sure it is used. So let's make sure that it actually does what they say it's supposed to do. So I've hooked up some clip leads, and I have a big, there we go. There we go, 0.5 ohm, 0.52, good. So that one's good. Like I said, 25 watts, and yeah, it looks pretty strange. Anyway, I like those. And then the big one I bought, which I have a use for, I believe, in an upcoming design that I want to do. I won't say what it is yet, but let's show that resistor. And this one is way cool. Let's see here, let's zoom out for this one, because it's big. It's in the box, brand new in the box. Vitrum radio resistors, result engineered. Nice. You don't want to have things engineered for no result. The Ward Leonard Electric Company. I've never heard of that. Mount Vernon, New York. So all my viewers in New York can give a shout out there. They have a nice little logo here, WL, Ward Leonard. And so yeah, it looks like it's new in the box, so the box is pretty crusty, but yeah, look at this. Here you go. Can you read that? 60 watts, type 160A, 160 ohms, 25 is stamped on there, 25 ohms, 160 watts. Okay, so let's see here. Let's see if we can get into this box. Yeah, there we go. Look at this. Here's the big reveal. Ooh, look at that. Ooh, some original packing. Look at that. What is the original packing? Oh, it comes with something. Oh, neat. What's it come with? Oh, good. So this would be cool. So we'll talk about this in a second. Let's get it out of its little box here. So yeah, really big, really big ceramic resistor, and adjustable, so you can move this back and forth. Okay, so that's way cool. And let's get out a let me get out a tape measure here. So if you don't have one of these tape measures, go get one. I know in the United States we're all about inches, right? And we kind of ignore metric. And it's actually really hard to find a tape measure like this. And I had to buy this one. I believe that these are a Canadian brand, if I'm not mistaken. Camella. Anyway, it's both English and metric, all in the same roll. That's great. Okay, so anyway, we can go here. We can say it is 8.5 inches or 220 millimeters. Very cool. And inch and a quarter, maybe 1.5 inches in diameter, like 30 millimeters. Yeah, it's big. And good for 160 watts. Okay, so what's in the magic bag here? It's kind of a waxed paper. Interesting. Mounting hardware. Okay. So I don't know if you've seen these before. Wow, how do those work? Well, they go in the ends. Okay. So there's a hole in the end, and you can push this in there, and it'll kind of collapse and it'll jam in there. It won't want to come out. So I'm not gonna jam it in there right now. But you put one on one on each end, and then you can bolt it down. And the nice thing about it is it holds it up, because this thing's going to get hot, right? 160 watts. It's going to get super hot. So you get like an inch of airflow underneath this thing. So yeah, oops, put this thing on the right way like that. Very cool. So original hardware, nice, all in the original box. I like it. So why do I need such a huge resistor? Well, I don't really, but it was $1.20. So I couldn't pass it up. $1.20. Oh my God. I don't know how much you'd have to pay with this thing. Whew, lots of money. All right, let's measure it. Bring over my ohm meter. Okay. What did I say it was? 25 ohms? Let's measure it. 25.03. Oh, 0.00. Nice. So very accurate 25 ohms. Thank you. You get what you pay for back in those days. And then if you went to this middle tab here, it's at 12.8 ohms on that side. And over on this side, it's 12.5 ohms, kind of in the middle. Very cool. So you can imagine having a load resistor like this for audio work. You can set it for 4 ohms, for 8 ohms, for 16 ohms. You just move it back and forth, and that would be great. Now it is inductive. It's a wound metal, so it will have a lot of inductance. But for like low frequency stuff, it'll be great. I want to use it as a load resistor for a particular project, like I said, I have in mind. And I don't know what resistor I want yet, and that's okay, because this one I can adjust. So that'll be good. Start part number here. Yeah, 160A, 25, WL. WL is Ward Leonard. Very nice. So, and no markings of where it's made, right? It was just, everything is assumed made in the USA. No need to say. Very cool. Brand new in the box. I don't see any solder or anything, so this one's never been touched. The other one had a little bit of solder remnants on the end here. Yeah, still a little bit of a lead there. Somebody snipped off. So interesting to find used stuff at the surplus stores. But yeah, I like it. All right, so let's use those other resistors. Let's use these, and let's build something. So what are these? These are Dale resistors, made in Mexico. These are 100 ohms, 5%, 5 watt. So if you put 2 together, you get 50 ohms, okay? So we're going to make a 50 ohm load. And we are going to make a very, very crude 50 ohm load. And people say, oh, that's no good. You have to control your blah, 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 blah. And so we will build it up, and then we'll sweep it with a VNA, and we'll see, you know, at what usable frequencies something as crude as this, you know, what kind of a dummy load is it? Is it good for 2 meters? Is it good for 440? Yeah, we'll find out. So I'm going to twist these leads together, okay? And I cut this side a little short. So let me get some solder here. And I'm going to put some solder on this side. I'm going to put some solder on this side. Now they're making good electrical contact. And I am going to, ow, geez, that's hot. I'll bend that down. All right. I'm going to use an old BNC connector that I pulled out of some piece of equipment and put it to new use. And I will just put these side by side. I'll get a bunch of solder on my tip so we can bodge these together. And there we go. Right there. Always hold it until it cools off. And we have, can you see that? All right, that's better. So we've bodged that together. And we have a ground lead sticking out over here. It still has a little bit of braid left on it. Well, that comes in handy. Look at that. Perfect. Perfect, perfect, perfect. Let's see. Let's go ahead and bend these around like this. Yeah, see what I'm doing here. I'm going to make the braid come over. Tighten that down. So there we go. So my little braid will come down and we will tack it on to this section over here. Let's put some more solder up higher. Put some solder there, lots of solder. Put some solder on the braid. All right. So let's cut this short here. There we go. And I'm going to stick that underneath. There we go. I've had a couple viewers now say I was the Bob Ross of electronics. So I take that as a compliment. Look at our little happy little resistor here. You don't have to do it the way I do it. You can do it any way you want. Bob Ross was interesting. One of my favorite episodes, he was talking about his son. His son showed up on his show once in a while. His son teaches art too. But on one episode, the son wasn't there. But he said something about the son lives with him. And he goes, you know, I've moved a couple times and my son seems to find me. Oh, I just thought that was hilarious. Every once in a while he says something funny that's just totally out of context. All right, let's tighten this down a little bit over here. Make sure we have a good RF connection. There you go. So we have this terrible inductor here and terrible inductor here and probably wire-wound resistors. So don't think this is going to work at very high frequencies. But it'd be interesting to know what it does work at, right? We have two 5-watt resistors, so it's a 10 ohm load. So 10 ohm load, and let's put it on the VNA and see how good this thing is. Okay, I'm calibrating here. Let me stir up the shorts. So I have a Nano VNA H4, the 4-inch version, and I'm using the Dislord software on it. If you don't know about this, go search it out, and what it does is it actually is way better than the original software. It allows 401 calibration points, so it's much, much better that way, and just has better software in general. So it does take longer to calibrate because it is calibrating over a larger number of points. So I'm going to say done. I'm going to save that in 4. Okay, so how did I calibrate? I have a SMA cable. I have a connector adapter here for BNC, and I'm using my BNC calibration section that I made before. And it uses nice small surface mount parts, and it's really good to a gigahertz and everything. So let's see how good these are gigahertz. So we're going to need an adapter here. It's right behind me. If I can get it out of the little plastic box. There we go. All right, so let's stick this on it and see how we did. And can you see that? Wow. So really, really bad, right? Woo! So all this inductance and stuff, yeah, is really, really bad. If we grab these, we can make them do all kinds of things. But let's see. Let me. Oh, this is really bad photography. Let me rearrange things here. All right, there we go. Let's do display return loss, and yeah, it's really, really bad. So then let's go back and let's change the scale here. Marker, and let me move the marker. Uh-oh. There we go, marker. So is it going to be worth anything at all? Wow. So let's change stimulus. Let's stop it at 30 megahertz. And so there you go. So can you use it for HF? All right. I say you could use it for HF. It's not going to be a great calibration load, but it's probably an okay dummy load. It's certainly good for 20 meters. Let's go ahead and change the let's see here, display format, SWR. So we have an SWR of 2:1 here. Yeah, so 1.5. So at, where are we? 16 megahertz, we have 1.5. That's fine. That's fine for a dummy load. And up higher, we have a SWR of 2:1. All right, so our very, very crude first attempt here gives us a really, really, really bad, really, really bad dummy load. So let's see if we can improve it. All right, let's take that here and let's zoom down. Let's zoom down here so we can see what's going. I think you can see everything now in the picture. So we have about, like I said, about a 2:1 SWR there. Really, really good over here. So why is it so bad? Well, it's probably this long inductor here. We had this long inductor. So how do we get rid of inductance? Well, we can make this wire really, really thick. So we can use copper tape. So if you don't have any copper tape, get some. Here's a roll of copper tape. It's not that expensive. So we're going to put a copper tape. We're going to put it on the BNC over here. It has conductive tape. Okay, it has conductive tape. And so I'm going to put conductive tape on it. So why would this change? Well, take a look. It's a much wider area, and it gives a path for the RF instead of that tiny little inductor. Now you've got the big fat thing, and it has very little inductance, right? And so look what we've gone from now. Now we're down to 1.8 with that change. 1.8. That's good. Let's see if we can't put a little bit more on. Maybe we need maybe we need kind of a little transmission line thing going on. So let's see if you can put some tape on this side without shorting things out, of course. If you're going to build this, you'd put it in a box, right? So it'd be completely shielded. So let's shield this side, and let's see. Oops. Let's see if the numbers go down. And they didn't really. They didn't. They didn't. But let's put tape. Let's put tape all the way around. Tape is cheap, like I said. I think every RF engineer has probably gone through miles of RF tape, or copper tape. It's very good for RFI work. If you're building a product and you need to pass an RFI test to get certified, you use a lot of copper tape to figure out where your problems are, and then you go back and redesign the packaging, make sure that there's no holes in the package. Okay, we're going to put that one there. We're going to wrap this one around. So now it's all enclosed. Now we have a perfect enclosure. And that's probably as good as it's going to get. So now we're down to 1.78. So it's helped a little bit, okay? So let's go wide again. Let's see. Stimulus. Stop frequency, 1 gigahertz. Yeah, there you go. So we've got this one loop thing going here. And not a lot we can do about it. It does come back around, interestingly enough. It's actually a good load at 685 megahertz. Don't ask me why. Something in there. That coil is probably resonating at that frequency and causing a zero in the standing wave. And yep. Well, there you go. So you want to build your own W load? Well, you're probably okay, in the HF bands, but anything above that you need to pay attention to, and this type of device is not going to make it. It looks very elegant, though, don't you think? All right, I know somebody's going to make a comment down below, so I'm going to try to stop them from doing that. And that is, well, how do we know this is a very good load? So I've put in the calibration load that comes with the Nano VNA, and you can see that, yeah, we still have a little spot there. Yeah. So this is a pretty good load. I covered this on one of my videos. You can go look it up of how to build this. But yeah, it's a pretty good load. It's not too bad.